This presentation will cover some aspects on trends in broadband radio technologies. Broadband can be provided over different platforms, as for example by fiber, wireless, satellite. The graph on the left-hand side shows statistics on broadband subscribers for wireless and fixed line communications. As we can see, the number of active mobile broadband subscriptions shown in pink color per 100 inhabitants continue to grow. With respect to the fixed broadband subscriptions, which are shown in red color. So in this presentation, we'll focus on the mobile broadband, shown in pink color. So this slide shows a brief summary of wireless communication evolution since the commercialization of the first generation of cellular networks in early 1980s. 5 generations have been launched, with enormous differences in terms of the network architecture, key technologies, coverage, spectral efficiency, and so on. I would like to emphasize that ITUR develops high-level standards, such as concept, performance requirements, specifications, and detailed standards that are used by manufacturers are developed by other organizations such as 3GPP, ETSI, and EEEE. As shown on this slide, all 3G, 4G, and 5G mobile broadband systems are based on ITU standards for IMT. At the moment, there are 3 standards for IMT: IMT 2000, IMT Advanced, and IMT 2020. Detailed specification of IMT 2000 can be found in recommendation 1457, so as shown in the first yellow box, and this is family of 6 standards, as indicated in this box. IMT 2000 corresponds to the 3rd generation and further updates. Then IMT Advanced is 4G standard, and it has only 2 technologies, LTE Advanced and Wyman Advanced. And if we consider mobile broadband and mobile phones, LTE is the only standard for it at the moment. And this is a big step forward because there is only 1 technology involved. Then detailed specifications of IMT 2020 of 5G terrestrial radio interface were approved in 2020. And standardization process of IMT 2030, known as 6G, is currently ongoing. So on this slide, the blue box shows the 4 radio interfaces contained in the 2nd version of recommendation 2150. The first and the second contained in this list are radio interface technologies developed by 3GPP. The third is universal radio interface developed by TSI, which is Indian company. And the fourth is DECT 5G developed by ETSI, a set of radio interface technologies. All radio interfaces are based on orthogonal frequency division multiplexing and MIMO technology for operation in the IMT spectrum. And they meet all the technical requirements in all selected test environments. There are some differences in the frequency bands supported and the flexibility of the bandwidth, as shown in this table. So this slide provides timeline for IMT 2030 and beyond. It is similar to the graph of IMT 2020 or 5G, but the years are different. The beginning was for 6G was in 2021, and the expected completion is 2030. With respect to 6G standardization, ITR has completed initial phase of development. The Radio Assembly 2023 approved the revision of Resolution 56, confirming the name for the next generation of IMT to be IMT 2030, and also approved the new recommendation of IMT 2030 framework, contained in Recommendation 2160. The work on the next IMT generation will further focus on the minimum performance requirements and the detailed evaluation criteria. From 2025 to 2027, the industry will provide candidate radio interface technologies, and ITU-R will start the evaluation process. As you may recall, there are three main scenarios in 5G. IMT 2020, which are improved broadband access, large scale of machine-to-machine communication, and ultra-reliable low-latency systems. Now, improved broadband becomes immersive communication. Large-scale machine-to-machine communication is transformed into massive ultra-critical low-latency communication becomes hyper-reliable low-latency, communication. And it is expected to add three new scenarios, such as ubiquitous connectivity, integrated artificial intelligence and connectivity, integrated sensing and communication. This slide lists 5 functions or parameters of IMT 2030, or 6G. 9 of them, shown in green color, already exist in 5G. For example, 6G will operate in motion at speeds up to 1,000 kilometers. Previously, it was 500 kilometers per hour. Latency will be improved to 0.1 millisecond, compared to 1 millisecond in 5G. The 6 new features of IMT 2030 are shown in blue color. They are related to the introduction of artificial intelligence, the use of sensing, and the improvement of geolocation. As you can see, the parameters are not set by specific value, as it was for 5G, but by the target range of values. For each IMT 6G use case, specific values of speeds, latency, and connection density will be determined based on the use case. With respect to IMT, there is very significant progress in radio access technologies, and I can mention, for example, carrier aggregation of discontinuous bands, including interband carrier aggregation that could allow wider bandwidths to be used. Then advanced waveforms and modulation and improved coding schemes. Then advanced technologies such as massive MIMO for 3D beamforming and active antenna systems that enable to achieve better spectrum efficiency. And non-orthogonal multiple access schemes. So one of very important element for success of IMT is the frequency resource. As already mentioned by Nikolai, ITU allocates spectrum for mobile broadband, including IMT, at World Radio Communication Conferences. So this chart shows identification of different frequency bands to IMT in different countries in 3 regions. For IMT, the WRC-23 identifies several mid-range bands at 3, 6, and 10 gigahertz. So these are shown with yellow boxes. And this will contribute not only to IMT 2020, but also to development of future IMT 2030, or 6G. And as it was already mentioned, the total of 1.3 gigahertz of spectrum was additionally identified for IMT by the conference in last year, in 2023. So now the new study cycle has already begun in the preparation for the conference in 2027. As regards broadband, the ITU study possible identification of new frequency bands at 4, 7, and 14 gigahertz for the terrestrial component of IMT. And these bands will be crucial for enabling new